We're doing section 6.7, which is to graph linear inequalities in two variables. We needed a sheet of graph paper, which you all have now. And the first thing that we're going to look at together is just determining whether these ordered pairs that are up here are actually solutions to the inequality that I have written. I want you to take a moment. I want you to talk to your partner to decide, how do you know if any one of those, or more than one of those one of those ordered pairs are actually solutions to the inequality? Talk to your neighbor, please. How do you determine whether one of those ordered pairs is a solution or not? Rebecca?
Don't you plug them in X and Y?
Exactly. You plug in the numbers for X and Y and see if it gives you a, what kind of statement? True or false. Whether it gives you a true or a false statement. So, would you please substitute 0 in for X and 0 in for Y, so that you're looking at 0, negative 0, the opposite of 0, heavens. Opposite of 0 is what, class? It's still 0. What's 2 times 0? And when you add 0 and 0 together, you get 0. So I got 0 is less than 8. True or false statement? True. So is 0, 0 a solution to this inequality? So I'm going to write the word yes. That is the appropriate answer. Or if you want to write solution, that would be appropriate as well. Then let's put 0 and 4 in. So the opposite of 0 plus 2 times 4 is less than 8. Again, the opposite of 0 is? 2 times 4 is? 0 plus 8 is? So I got 8 is less than 8. True or false?
False.
Really? False. How come it's false? Because it's not equal to. Because it's not or equal to. So since that is false, what will our answer be as to whether it's a solution or not? No would be appropriate. And here, not a solution. This is when not a solution would be an appropriate answer. Is it a solution? No. No, it is not a solution. And the last one, put that 3 in for your X and 5 in for your Y. And let's see what we come out with here. 2 times 5, class, is? So I got negative 3 plus 10 is less than 8. Negative 3 plus 10 is? 7 less than 8. True. So therefore, the answer is? Yes. Or we could say solution. Is it possible that I'm going to have more than one XY pair as a solution for an inequality? Absolutely. Absolutely. All right. Any troubles there to begin with? Okay. Now, when we get into graphing these, there are a few steps that you have to take, and I want you to jot these steps down. First of all, you have to graph the line. Then, we get to decide whether it is a dashed line or a solid line. Just like we decided whether it was an open circle or a closed circle when we were doing it on the number line. And the last part, we get to shade part of the plane. And we can do that through testing a point, or there is a little shortcut, and I will talk about what that shortcut is here in just a moment. I'm going to give you the rest of the time to finish writing down. Okay, as I was commenting, you're going to graph the line like you always have. You need the slope, the y-intercept, or you can graph using the x-intercept, y-intercept. We're going to have to decide whether the line is dashed or solid, depending on whether it is or equal to or not. And or equal to means we want to include all the points on the line. That's why it makes it solid. Just the less than, greater than is going to be a dashed line. We want to get up as close as we can to the line, but not include anything on the line. The last part here is when you are looking at a coordinate plane and you've got a line drawn, you want to know whether you're going to shade above that line or whether you're going to shade below that line. One of the things that you can do is you can test a point. And for example, you could put in the point 0, 0, and see if it makes a true statement. Just like you guys were doing one tile back here. And if it makes a true statement, we want to shade the area that that point is in. If it makes a false statement, we want to shade the other side. This bottom section, if you have y is greater than, and you have the rest of your inequality written on the other side, y is greater than, you're going to shade above the line. So this is y is greater than, above. And if it says y is less than, you're going to shade below the line. Y less than goes below the line. That only works when y is on the left-hand side and it's like in y equals mx plus b format. It's got to be y greater or y less. Everything else has to be on the right-hand side. Then you can use that nice little shortcut to say, oh, greater goes above the line, less than is shaded below the line. And we'll go through and do a few of these so that you can see that happening. You have that in your notes, please. You have your graph paper out. The first thing we're going to do now is we are going to graph y is greater than 4x minus 3. As we look at this, let's determine whether we're going to draw a solid or a dashed line right away. Okay, I'm hearing two different answers. I'm hearing both solid and dashed. Dashed, why? Because it's just a greater. It's not a greater than or equal to. So when you actually graph this line, would you use your straight edge and do that dashed line? If you need a straight edge, you know where to get them off of my desk. Let's get this taken care of, please. Yeah, I can already hear that might have a little troubles here. When we graph a line, what are two things that we need in order to graph that line? Jordan?
Y-intercept and the slope.
Y-intercept and the slope. When we look at this inequality that's up here, do we know what the y-intercept is to this inequality? What is it? It is not 3. It is negative 3. What is the slope to this inequality? 4, or 4 over 1 if you need that. Make sure that you graph your y-intercept and then use your slope to come up with another point, and then you can draw your line. Go to it. All right, Rebecca has drawn our line up here so that it is a dashed line going through the point negative 3 on the y-axis and then a slope of 4 over 1. Any problems with graphing the line itself? Now we're going to decide which side of the plane to shade, and we're going to do that both ways. We're going to look at testing a point first. Since this line does not go through the origin is a nice point to use. So I'm going to just put a dot there for a second and say, okay, what if I put 0 in for y and 0 in for x? What kind of a statement do I get? True or false? 0 is greater than, Jordan? Negative 3. Jordan, is that true or false?
True.
That is a true statement. That means that I want to shade this side of the line to include that point. So I'm going to pick up my pencil, and you guys are going to shade very nicely. I can't shade quite as nicely as you can, I don't think. Let me see here. I'm going to get my highlighter. Maybe I can do it really nicely. You guys are going to shade this entire section. Doing it in a lovely highlighted green. It's way over here. You should close in everything in the section that you have all the way to the end. Okay, now, very lightly with your pencil, because when I pick up your tests and your quizzes and stuff, I don't want to have graphite all over me, okay? So just nice lightly. Yep. Okay. Now, Kayla's got it lightly down there. That looks good. Just lightly. It doesn't have to be real dark. In fact, you'll kind of wear down your pencil if you do it real darkly. Awesome. So we just have graph now the inequality, and every point in this green shaded area that I have is a solution to this inequality. Pick a point. any point you would like out of this green inequality. Any point that you want. Ben?
-2, 3.
-2, 3. So that's this point here. Let's see if it makes it work. -2 is our y, greater than, no, -2 is not our y, is it? Nope. What number is our y?
3.
3 is our y. 3 greater than 4 times -2 minus 3. 4 times -2, class. -8. -8 minus 3, class. -11. Is 3 greater than a -11? True statement. Okay, it should work. It's in the green shaded area. Please choose an XY pair that's not in the green shaded area. Jake?
What's the 4 times -2 from?
Okay. Could I have an XY pair that is in the white area over here? Just any XY pair you want. Ellie?
6, 6.
6, 1, 2, 3, 4, 5, 6. So this point up here. So we're going to put in 6 greater than 4 times 6 minus 3. 4 times 6, class, is 24. So I got 6 is greater than 24 minus 3. 24 minus 3, class? 21. Is that a true statement? No. So nothing over here in this white section should be stated because none of them make the statement true. Jake, can you sit up, please? Thank you. Any questions there so far? Jordan? Good? Oh, let me go back here just a second. Now let's talk about whether it's y greater than or y less than. Let's use the shortcut in order to determine which way to shade. When you look at this inequality that we had up here, we had y greater than 4x minus 3. The greater than symbol says that I need to be above this line. So I shade above the line. It can be that simple. You don't even have to check a point. You can, but you don't have to. It's 2 ways of working at it. Okay. What I oftentimes do is I go to the y-intercept and go up the y-axis. What part of the plane is included when you're going up the y-axis? Because this is a greater than. I want to be on that side of the plane. The other one would be down the y-axis, and that would be y less than. So we don't want to do the y less than because it's a y greater than. It's above that line. Questions there? Well, we'll use it on the next one as well. Let's do x plus 2y is less than or equal to 0. As we were commenting earlier, we said you can put it in y equals mx plus b. That's one way to graph a line. What's another way to graph a line? Using the, right now it's sitting in standard form, isn't it? Using the x-intercept and the y-intercept, put 0 in for one, solve for the other. You can use that too, that's okay. Would you go ahead and graph this? Show your neighbor what you got when you graph. All right, let's come back to the front, please. When you are graphing this, some of you are changing it into y equals mx plus b, which is wonderful. You got 2y less than or equal to 0, not 0, less than or equal to, we've got to put the x on the other side, so that would be a negative x. And then when you divide by 2, now you have 1/2, a negative 1/2 times x. What's your y-intercept on that? What's your y-intercept on this equation? Ellie?
0.
0. Because we're adding 0 on there. So our y-intercept is 0. If I had used my x-intercept to be 0 and my y-intercept to be 0 up here originally, I've got the same point. It's difficult to graph that one that way. So that's why some of you might have looked at it and gone, okay, x-intercept is 0 and y-intercept is 0. Yes, that's because the whole line goes through the origin. So you actually do have to graph this one using slope-intercept. What is the slope? What is the slope? Jack? Negative 1/2. Can you come up here and graph that? Jack has the line drawn. It is solid because it's an or equal to statement. And we have the slope of a negative 1/2. when we're choosing a point, I can't choose 0, 0, because that's a point that actually lies on the line. It's not going to help me. But I could choose any other point that does not lie on the line. Anybody got a point that's real easy numbers maybe that we could use? Ellie?
1, -1.
We could do 1, -1 here, or we could do 1, +1 up here. And we know for sure that one doesn't lie on the line. Does that make sense? Yeah, we could even do -1, -1 if we wanted to. Sometimes when people are not as good at drawing their lines, you don't want to be too close to the line when you choose your point. So we'll go ahead and we'll put in your 1, -1 that you have there. 1 plus 2 times a -1 less than or equal to 0. What's 2 times a -1, class? -2. So now I have 1 minus 2, which is -1. Is -1 less than or equal to 0? True or false? True. So we want to shade the section below that includes that point that Ellie had given us. Had we used the point 1, +1, what's 2 times 1, class? 2. What's 1 plus 2, class? Is 3 less than or equal to 0? That would have been a false statement. We would not have wanted to shade above there. Now, stop just a second in your shading. This equation up here, the way it's originally written, I cannot decide whether it's above or below shading. But I can decide whether it's above or below shading when it's in the y equals format. This says y less than or equal. Jake, you need to have your eyes open, please. Sit up. Thank you. Y less than or equal is still telling me that we want to be shaded below the line. I want to be going down that y-axis, everything below the line. So pick up your shading tool, and now you can do your shading. So we want everything below that line shaded in. I want to use the pen on here for this because I don't want to scratch the board. I'm using just a finger pad of my finger. So we have all the shading below the line. If you want to have it in y equals mx plus b and you use less than, it's below the line, greater than above, and you just know to shade that way, awesome. You want to pick a point and test that point. Remember, Ellie's point made it true. That's why we shaded on the side with Ellie's point. My point, the 1, 1, made it false. We didn't want to shade on that side. Cecilia.
Why does it have to be in like y equals mx plus b? Like to know where to shade it? Like it's something like this.
What happens is sometimes you have a negative that flips the sign, Cecilia. Like if you divide by a negative. If I had this as x minus 2y is less than or equal to 0, it no longer is a less than or equal to once I put it in y equals format. It now becomes a y greater than or equal to. Okay, so I just caution you. If you always make sure it's y less than or equal to, y greater than or equal to, you will have no troubles in knowing which side to shade. If it's in standard form, because of negatives, things can flip with the division and the multiplication. Okay? Okay. All right. It's not to say that sometimes you look at it and you go, I can figure that out, but you're probably putting things across anyway and getting it into y equals. Okay? Be careful of the negatives. Those flip the inequality symbols. Yes, Angela.
I'm kind of confused on how you change it from like that form to like y equals mx plus b.
You have to isolate the y by itself. And remember that when you do so, you are going to be moving other terms to the other side. You know how we subtract x on both sides? Well, that's how I get my negative x. And then how do I undo division or multiplication? I have to use division. I'm dividing by 2 on both sides, which is the same thing as multiplying by a -1/2. Those are things from first semester, chapter 3, that we might need to go over a little bit if you are a little fishy on that, okay? All right. Anybody else? All right, let's go on here then. Now we get to graph y is greater than or equal to a -3. I caution you, remember some of the graphing that you did for homework today on the coordinate plane. I caution you, go ahead and graph and talk to your neighbor. So Jordan has drawn a horizontal solid line down at -3, and she's indicated that we're going to shade above because it is y is greater than that -3. So you think about going up that y-axis, and we want everything shaded above that line. So we will just start shading right here, and it's going to be everything above there. I'm not going to take too much time to fill all that in. Your pencil works much better than my highlighter up here does. So everything's going to be filled in above. We can pick any point in that shaded area, and it will give us a true statement when we substitute it in. Any questions there? Y greater, Y less are horizontal lines. What about X less and X greater? What kind of lines are those? What do we call this? Vertical, that's right. They can't see us going with our hands, so if they're listening to us on the internet, we gotta go up and down. So I need graphed X is less than a -1, please. Please. On this, Jake has graphed X is less than a -1. He graphed actually X equals -1, first of all. He's got a vertical line. He made it dashed because we don't have an or equal to up here. But now some of you have been asking me, how do you know which side to shade? I want all x's less than a -1. And when you look at your x-axis here, this is -1, right? What number is over here? -2. What number's over here? 0. Which one is less than a -1? -2 or 0? -2, so we want to go this way with our shading. We need to be smaller than that line. So we want all of the shading to be to the left of that line.
Wait, so
Everything to the left of it. Pick any XY pair you want out of there. The X will be less than a -1. Pick any XY pair out of there. The X will be less than a -1. It's the only number you can put into the inequality because there's no Y in that inequality.
oh, so it's less than so there's a left.
Exactly. If it were greater than, it would have to go to the right. If I wanted my X's to get bigger and bigger and bigger, I'd be going this direction. This would be X greater than -1 in this case. Questions there? Right. And we're going to do a story problem. You have 2 summer jobs at a youth center. You earn $8 per hour teaching basketball and $10 per hour teaching swimming. Let X be the amount of time and hours you teach basketball each week, and Y represent the amount of time that you teach swimming each week. So X is basketball, and Y here is swimming. Your goal is to earn $200 per week. So this is your goal right here. You have to write an inequality that has an X and a Y in it. That will get you to your goal. Why don't you talk to your partner, see if you can't come up with the inequality right now, please. Yes, 8x plus 10y greater than or equal to 200. Everybody had them on the boards. Very good. We have $8 times every hour that you're teaching basketball and $10 times every hour that you're teaching swimming. When we add that money together, it says at least 200, so that means it can be more than 200, but it can also be equal to 200. So please make sure that you have that down. Now the next thing that we want to do is we want to graph this inequality. Here's my graph paper. Let's write this inequality down one more time so that we can see it up here in front of us. Is greater than or equal to 200. My graph paper here, I'm going to use these as my axes. I'm going to have my axes here and here for my X and Y axis. With your graph paper that you have, ignore your XY axes on your graph paper and just treat the whole thing like the first quadrant. Does that make sense? Okay. So should we use slope intercept or should we use XY intercepts in order to graph this? Any thoughts? Why don't you take a moment and see once what the x-intercept and the y-intercept are. Do we have our x-intercept and our y-intercept? Do I have a volunteer for my x-intercept? Remember, you're putting 0 in for y and solving for x. So when you put 0 in for y and solve for x, I got 8x greater 8x. You can even say just equals 200. We don't have to worry about the inequality. What's 200 divided by 8 on your calculator? 25? Okay, so we get x equals 25. We know that's where it crosses the x-axis. Okay, now put 0 in for the x and solve for the y. So you got 10y is equal to 200. What's y equal to? 20. So we know our y-intercept is at 20. We don't want to go by ones on this graph thing. My x-intercept's at 25 and my y-intercept's at 20. We don't want to go by ones. What should we go by? Fives. Okay, 5 sounds great. Do I have a volunteer to come up here and take care of this if we're going by 5s? Any volunteer at all? Ben, you haven't been up here yet? Okay, go ahead and graph. When we graph the x-intercept and the y-intercept, the x-intercept means this is the point, 25, 0, because we put a 0 in for the y, we solve for the x. The y-intercept means the point 0, 20, because we put a point in for 0 in for x, and we solve for the y. Now we have to determine whether we're going to shade above this line or below this line. Pick a point. That's the easiest way to do this kind. Pick the point 0, 0, and put it in to your equation. 8 times 0 plus 10 times 0 is greater than or equal to 200. Eight times 0? 0. 10 times 0? 0 plus 0? Is 0 greater than or equal to 200? No, then we don't want to shade below this line. Where do we want to shade? Above this line. That is so right. So we're going to take everything, and please note what I'm doing. I'm sliding along the x and the y axis. Why am I doing that? Why am I not shading all the way on the other side of the x and y axis? Any thoughts? Ellie?
Because we don't know where the line is, so we can't go that far.
Well, if I had the rest of the graph, I mean, technically this line could keep going on this direction, right? But I don't want it to go on that direction. Whoa, that just took away all of my shading I just got done doing here. I don't want it to continue on. What kind of numbers are sitting over in that second quadrant for me? Negatives. What kind of numbers are sitting in that fourth quadrant? Negatives. Can I have negative number of hours of swimming and negative number of hours of basketball? Absolutely not. So we stop at these axes here. And so just the points that are in this first quadrant are the points that I want to deal with. Now, we've graphed it. You've got your shaded. We go back to this question. It says, give 3 possible combination of hours that will allow you to meet your goal. So we come back to the grid. And you need to come up with your partner. You need to come up with a point that'll allow us to be a solution. Okay, every set of partners is going to come up with a point. Wow, look at all those points in there. Are they all solutions? How do you know they're solutions? They're in the shaded area. Okay, that's a good point. You could check each one of them, couldn't you? Yes. Nobody chose any points on the line. could solutions be on the line? Absolutely. And if we had done this graph by ones, it would have been a lot easier to see some of those points on the line. But all of the points that I see up there now, hopefully everybody has the right XY pair with them, are solutions because they're in the shaded area. Jordan?
If the line was dotted, could it have still been on?
No. If the line were dashed, they cannot be on the line and be a solution. You can get up as close as possible to the line, but not include any points on the line. So how many solutions are there to this problem? One solution? Oh, I see a lot more than one up there. An infinite number? Maybe. Let me go back here for just a second. Usually students say to me, Mrs. Egan, isn't there a certain number of hours in a week? How many hours are there in a week? Let's see, there's 7 days in a week. There are how many hours in a day?
68.
168 hours in a week. All right. When I look at your graphs here, did anybody go over, if you add the X and the Y together, did anybody go over 168 hours? This is 30, 40, 50, 60, 70. 40, 45, 50, 55. What? Now here was 70, 70. What's 70 plus 70? 140. So I could still have 70 hours of each. 140 hours out of 168. Possible? For 70 hours basketball, 70 hours swimming? Another question, when am I going to sleep, right? Yeah, Angela's like, yeah, you got to sleep some. That only leaves me, what, about 28 hours to sleep, 4 hours a day? Some of you complain like you only sleep 4 hours a day. Some of you had your heads laying on the desk, you must only sleep 4 hours a day. Maybe 3 hours a day. Okay, so there are lots of different solutions. I want you to realize that when I ask you a question on the test, and I say, give me 3 possible solutions to the inequality. You guys had a lot more than 3 here. As long as it's in the shaded area, it's a possible solution to the inequality. Any questions there? Awesome. Then we are going to go on to page 943 out of your textbook. You're going to do 4 problems for me, number 68, 67, 68, 69, and 70. You're going to do these with your partner. And I have answers on the next slide for you. So please do those 4 problems, page 943, number 67 to 70. Just do them on your notes that you're taking there. This is part of class. Thank you.